is physical design flow. What is a physical design? Physical design is a process of converting gate level netlist into the GDS form. Physical design is contains the import design, floor plan, power plan, placement and optimization, CTS and optimization, routing and optimization, sign off. These all are steps in the physical design flow. In the import design, here we will use the inputs like technological file, .lib file, .leaf file, and get level netlist, SDC. These all information we will give. After giving the inputs, we will come to the floor plan stage. Floor plan stage, here we will create the core area and the die boundary. We'll place the macros, we'll place the IO ports for the communication purpose, and we will place the physical stage. It is the floor plan stage. After the floor plan, we will come to the power plan. Here we will give the power connections to the circuit. We will like VDD versus power supply. We will give after the power plan. We will come to the placement and optimization. In this stage, we will place the standard cells inside the core area with the optimization. After completing the placement, we will come to the CTS stage. CTS is a stage we will create the clock test synthesis. In this stage, we will connect all the clock pin of the registers. After this, we will routing stage. Routing is a stage where we have to connect the physical connections between all the standard cells by using the metal layers and vias. With the optimization, we will do sign off. Sign off is the last stage of the physical design. In this stage, we will check the quality and performance of the design. It is a complete all steps in the physical design. We will see details of each steps. Physical design and in details. Import design. Import design is the first stage. In this stage, we will give the inputs like technological file, .lib file, .leaf file, gate level netlist, and the SDC. Technological file. Technological file contains the information of the metal layer such as width of the metal layer, spacing between the metal to metal, and metal pitch, metal color, and via cuts, via enclosure, metal density. All information contains the technological file. .lib file. .lib file contains the delay information such as input transient, the output capacitance, setup, hold, and internal power and the leakage power. These all information contains the .lib file. .leaf file. .leaf file contains the physical views of the standard cells like width of the standard cells, height of the standard cells, IO port locations, IO port directions, OBS, abstractions, and it also contains antenna ratios. Gate level netlist. Gate level netlist is contains a logical connectivity between the standard cells. This is output from the synthesis. We will give to the inputs the physical design is a SDC. SDC is also output from the synthesis. SDC contains the informations like timing, area, power, constraints in the TCL base is also it is also contains the operating conditions, wire load module, clock definitions, exceptions. These all information contained in the SDC. We'll give all the inputs to the in the input design. Is a in this after giving the inputs, we will check the given inputs are correct or not. If the given inputs are correct, we can move to the floor plan stage. We are having errors in the gate level netlist. We have to inform to the RTL team. We are having the errors in the libraries. We can inform to the top levels. After, if the inputs are correct, we can move to the floor plan stage. Floor plan is a stage where we have to create the core area and the die area and placing of net of macros, IO ports, physical cells with the legalization. It is a floor plan stage. In the floor plan stage, it is completely core area. These are the side rows. These all are side rows. Blue color lines, every blue color lines are the side rows. These are the IO ports. Everything are the IO ports. These are the macros. IO ports are placed for the communication purpose with the other blocks and giving the voltage and power to the inside the core area. In this floor plan, we will place the physical cells like end cap cells and the tab cells. End cap cells are placed at the end of the side row. Here we all are end cap cells. Here is also all our end cap cells. Here is also end cap cells. To avoid the well proximity effect. Tab cells. Tab cells are placed to connect the body connections. After placing the tab cells on the end cap cells, we will check the legalization and the correct placement of the IO ports. If these all are correct, we can move to the Power plant stage. Power plant is a stage where we have to create the VDN VSS power steps inside the core area and VDN VSS power steps around the core area for connecting the standard cells. It is a complete power plant structure. In this power plant structure, it is a power ring. It is a power ring. It is completely here. It is power ring. It is completely yellow and red color is mentioning is this red color is and yellow color metal is a power rings. Viridian VSS power rings. Viridian VSS power rings are formed around the core area connect the power from core ring to the macros and the macros in the core area. Power types. Viridian VSS power types are formed from inside the core area to tap the power from core ring to the core area. Is the power types. Power rails. VDN VSS power rails are to the standard cells. To connect the VDN VSS power rails to the standard cells to tap the power from power types to the standard cells is the power rails. See, this it is a powering. These are the power types. This, this is power type. This is all power types. Power vias. Power vias are kind of interaction between two metal layers is a power vias. After completing complete power plan, we will check the power plan is correct or not for using the sanity checks. Any floating metal layers is there or not? Is there any missing vias? Is there any opens or shorts? We will check. If we are finding issue, we are having like these errors, we can fix those errors. After fixing only, we can move to the placement stage. Placement stage. Play in this stage. Placement is a stage where we have to place the standard cells inside the core area with the legalization and the optimization. It is a course placement and global placement. In this stage, all the standard cells are not placed at exact side row. There is overlapping between the standard cells. It is a detailed placement. In this stage and a legal placement. In this stage, all the standard cells are placed at exact side row and without any overlapping. Placement is contains these all steps. First one is initial place to initial place, initial DRC to initial DRC, initial opt to initial opt, final place to final place, final opt to final opt. Initial place to initial place. In this stage, it is starting. In this stage, course placement. All the channel cells are not placed exact side row. There may be overlapping between them. Scan chain optimization also happens in this stage, and buffer awareness timing also takes place in this stage. Wherever the timing is not meeting in that path, the addition of buffer it will take place. Initial DIC to initial DIC. In this stage, high finite net signatures it will take place and it will fix the max tense and max capacitance violations also. Initial opt to initial opt. It is the optimization stage. It will fix the timing. After the optimization, final place to final place. In this stage, it is a legalization placement. All the standard cells are placed at exact side row without any overlapping. Final opt to final opt. It is a optimization step. If the timing is not meeting before previous stages, it will meet completely. Timing will be meted. After the five stages, we will check the check sanity checks. If the legalization is correct or not, we will check the check legalization. Timing, we will check the timing should be meted or not, and we will check the conjunction values. Conjunction should be minimum, and utilization we will check. These all values we will check. If these all are minimum, we can move to the CTS stage. If we are having the conjunction is more means we have to reduce the conjunction values. If the timing is not meeting means we have to meet the timing. Legalization should be correct. After these all are correct, we can move to the CTS stage. CTS is the insertion of buffers and inverters along the clock path to balance the clock delay of the clock inputs of the different flops of the in the same design. Is a clock tree synthesis. It is a clock tree. It is a clock port is connect. A single clock port is connected to all the clock pin of the registers. Here is everything. Everyone is registered. It is a clock pins connected. It is a clock ports connected. After completing the complete CTS, we will check the timing, skew, and the latency. Either timing should be meted. If the timing is not meted, we will check that we try to meet the timing. We'll set the target skew and the target latency. It should be minimum. If we are having the more than target latency values, skew values, means we have to fix those values. After fixing only, we can move to the next stage. That is called routing stage. Skew and latency. What is skew? Skew is the difference between the clock source latency of the capture flip-flop and the clock source latency of the launch flip-flop. Here is the FF2 is the capture flop, FF1 is the launch flop. From year to year, from year to year. What is the latency? Latency is the total time taken by a clock signal to move from its start point to end point of its destination. Latency is like this. Year to year is latency. Here is also one latency, and here is also one latency. What is global skew? Global skew is the clock source latency of the largest capture flip-flop and the clock source latency of the smallest launch flip-flop. It's a global skew difference. Year to year is a Fn minus FFN minus FF1 is the global skew. F2 minus F1 is the skew. Latency is this one. After this, if the skew and latency are minimum and timing should be meted, we'll move to the routing stage. Routing is a stage where we have to connect the physical connection between the standard cells using metal layers and the vias according to the logical connections. Routing is having the four stages. One is the global routing, track assignment routing, detailed routing, and the search and repair routing. In the global routing is it will find the possible path for the routing, and it will not do any DRVs fixing, and it will not do any timing fixing. After the global routing, we will come to the track assignment routing. Track assignment routing is done according to the global routing only. It will not do any DRV fixing. It will do the timing fixing in this stage. After that, detailed routing. Detailed routing is a complete routing. In this stage, complete routing it will take place and it will do the DRV fixing also. It will do the timing fixing also. Search and repair. It is the last stage of the routing stage. In this step, we will check after the first iteration of the routing. We will do the search and repair. Is there any opens or shorts? We will fix them and we will do the again the routing. It is a routing stay like this. We in the design we will see after routing. After routing, we will check is there any opens or shorts, DRVs, and timing. If the timing is not meted, we will meet the timing. If we have to opens or shorts, we are having opens or shorts. We have to fix the manually. After if we fixed, after we read the gate level at least SDC and the parasites. These all outputs of the ICC tool. After last stage is a sign off. Sign off is a stage. It is the last stage. Here we will check the quality and performance of the design before sending to the fabrication unit. We'll check the is there any quality and performance of it will work. We'll check the sign off is a logical equivalence check, electromigration, the airdrop. Is there any electromigration airdrop in our design? ECO cycle is for the timing meeting. We'll do LVC logical equivalence check. We'll do electrical rule check. We'll do ECO cycle. In this ECO cycle, we'll do like this. Use a PT shell. Fix the timing. We'll do the complete iteration cycle. We will do. It is complete details about physical design and its flow. Thank you, everyone.